here we have a quartic function. It's got roots at it's got a bounce at -2. It's got zeros at 1 and 5. It says if you divide by x minus 3, the remains 50. So let's first set this up. So f of x is equal to, we need to write the roots in. So x plus 2 times x plus 2, x minus 1, x minus 5. Okay, what we really want to make sure we don't forget though is that a value. There's always going to be an a value here. Okay, and that's going to tell us the direction and also any compressions or expansions that are involved here. Okay, so it tells us we need to be able to solve for a essentially, but they only tell us the division statement here. We divide by this factor, we end up with a remainder of 50. Well, it's important to note that the remainder theorem states that if I divide by the root, I end up with the remainder. Well, this implies then that those are x and y coordinates. So this is actually a coordinate on the graph. So if I were to draw this in, I have a bounce at -2, I have a 0 at 1, 0 at 5, and then at x equals 3, I have a y coordinate of 50 up here. That should kind of be more in the middle, but I have a y coordinate at 50. Okay, so that's the remainder theorem also implies that we have actually an x and y pairing. So we can actually use that coordinate to solve for a. So when I substitute in, I get f of 3 is equal to 50, which is equal to a times 3 plus 2, 3 plus 2, 3 minus 1, 3 minus 5, and then we can solve for a. So we end up with 25 times 2 is 50, times -2 is -100. So we end up with 50 is equal to -100 a. So a works out to be -1/2. Okay, so that means it's an upside down. So it's going to come like this. It's going to bounce. It's going to go through this 0. It's going to go through that point there and go through the 0 again like that. So that's what the graph's going to look like. And then my equation of this graph ends up being, I should write it in the f of x form. F of x is equal to -1/2 x plus 2 squared x minus 1 x minus 5. Okay, so there we go.